Hey everybody, just wanted to help out with your first assignment for our course. I'm using a different data set so that I don't give away the answers, but it's the same idea. Okay. The first task is to open up that heart rate data set, which is at the bottom, and identify the variables in the data set. Okay, so I'm pretending this is like the data set you're going to use. If I'm going to identify the variables, I'm really looking at the columns. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 columns of data in my data set. There's really 10 variables I should be identifying. The variables are the policy number, the expiration date, the location, the state, the region. You get the idea, right? If you have a well-prepared data set, the variable name should be the header row, that first row up here, like I'm highlighting. Those are my variables. And if I have to classify each variable as qualitative or quantitative, going back here with policy number, I would classify this as qualitative because there's no meaningful arithmetic that can be done with these numbers, right? Quantitative are numbers, but not just any old numbers. They're numbers where you can add them and subtract them, and it helps provide you some information. If you were to find the mean policy number, would that tell you anything? You know, the mean policy number, that just tells you whatever structure you have for generating these numbers, it tell you what the center is. That doesn't really tell us any information. Okay, so policy number is a confusing one for this data set, but it's a good one to go over. We should classify this as qualitative. It's a category to put everyone in. Expiration date. This one's probably a little debatable. You won't have anything that's debatable in your heart rate data set, okay? But this one's a little debatable because if you could change expiration date to like the number of milliseconds since January 1st, 1970 or something like that, then it's, calculating the mean is important. So this one could be qualitative, it could be quantitative. Right now it looks qualitative because it's not structured as a number, okay? Qualitative are variables that are not numbers or numbers that don't have any real, meaningful arithmetic to be done with them. Location, now this is clearly qualitative. It's a category, which is another word for a qualitative variable is a categorical variable, something you can put a category in. Your category is urban or rural, so location is a qualitative variable. State is a qualitative variable. Region, that's a qualitative variable. It's a category you can put people in. Now, insured value, this is the first definite quantitative variable in my example data set because it's numbers, and more importantly, it's numbers where calculating the mean would actually tell us some information, okay? Insurance value, the insured value, if we found the mean amount of all these policies for our insured value, then we know a typical insured value for this policy. Okay, qualitative, everything else is qualitative. So something with numbers where you can do meaningful arithmetic is quantitative. Okay, and so it said if you identify it as quantitative, you got to decide whether it's discrete or continuous. So this insured value, you could say it was discrete because there's a definite amount of options. If there's decimals, that's really leading you towards continuous, okay? If there's a bunch of decimals, then that means that there's probably an infinite amount of different options, and that's what a continuous variable is, a variable where there's a lot of different options. So with quantitative, you have to classify as discrete or continuous. That's how you do it. Discrete means there's no decimals. There's a countable amount of outcomes. Continuous means you could have decimals. There's an uncountable amount of outcomes depending on how accurate you want to measure it. Specify possible values for each variable. So I won't do that for all 10, but for this one, like I'm going to sort it from least to greatest. Up here, I'm going to click off screen. I think it's data, sort and filter. It's not letting me. There must be something wrong. But what I'd want to do to find the possible values is find the smallest amount, which you can do in Excel real quick. Here I'm going to scroll to find an empty cell at the bottom here. And if I want the smallest value of a data set, I'm going to type equals min, open a parentheses, and then you can click and drag all the data set that you want to find the minimum number for. That way you don't have to sort it or go looking through every single number to find the smallest. And there's the smallest values, 30,000. And if I want max, I type equals max, open a parentheses, and then do the same thing, click and drag. And the maximum goes off screen, so I can expand this. So For this question, specify possible values anywhere between 30,000 and 53.4 million. Give a brief written description. Okay, you probably know what to do here. Just tell us what the numbers in that heart rate data set actually mean for us. Okay, and I think that's everything. So again, I used an example data set. You should be using the heart rate data set. That way I didn't give away the answers, but I hope that helps you. You can always message me if you still need help and still have questions, though, okay?